In this video, I will solve a ANN project with the help of PyTorch from scratch, and I will explain you that how we can write code for back propagation and forward propagation. I will provide the link of whole the notebook and the dataset which I used in the description. First, we have to import the pandas, and first we have to read our data. So after that, we can see in our data we have our categorical feature. So we have to convert it into our numerical feature by using pd.get underscore dummies. After that, we have to separate our data into our independent and dependent features by using iloc, and now we have to split our data into training and testing data from sklearn library. So as we can see in our data, we have different ranges of each columns. So I have used a standard scaler, so it will change my scale from -1 to between -1 to 1. So as we know, our PyTorch always needs tensors to work. So, and I already talked about all these libraries functionalities in my previous video. So as we know, our PyTorch always works with the tensors, and tensors should be in our float numbers. So in that case, and PyTorch cannot convert our my data frame into our tensors. So first we have to convert my data frame into array, then we have to convert into float. So for that, I have used first np dot as array x train. So it will convert my data frame into array, then it will convert into my tensors. So I perform both this operation in my training data and in my testing data. So after that, after converting into tensors, I have written a code in the OOPS language of Python. So first I have module that I am using torch.nn.module in our class ANN. After that, I have initialized my first layer. It will be the input layer, and it will be the first hidden layer, and it will be the our second hidden layer, and it will be my output layer. So if I explain you, we can see in our data we have uh, eight eight columns. In my X data we have eight columns. So we have to write in my input layer we have to provide 10. Suppose we have starting 10 input layers. After that, I have joined these layers with 15 hidden layers. Suppose in this hidden layer H1 we have 15 neurons. After that, in our H2, 15 15 comma 11 means these 15 neurons will connect it to 11 neurons in hidden layer 2. So this is for H2. We can say it is for H1 to H2 to connect H1 to H2, and it will connect our input to hidden layer 1, and it will connect our hidden layer 2 with hidden layer 3, and it will connect our hidden layer 3 to our output layer. So in this operation we have 11 up to 11, and in our hidden layer 3 we have 12. and it will connect to our output. So, and in a forward propagation function, I have defined that in my first layer, it will connect with ReLU activation function. And it is our second layer and third layer also will connect with ReLU activation function. So after that, I have initialized my class with an object with the name of neural network. And I am assuming that you all know the basics of Python with OOPS language because PyTorch supports only OOPS. So in that, this code is for our back propagation. So we are defining our here loss function. And if you don't know about this and loss and all these libraries, go to my playlist and see the second video of my PyTorch introduction. There I defined all the libraries and the functions and the other functionalities and the basic of PyTorch. So in our optimizer function, we have our parameters known as LR. This is our learning rate. This is our learning rate of our optimizer. And these are the parameters. These are the same parameters if I talk about. So let me execute this. Okay. So we can see our parameters is nothing but they will show us the okay they will show us that how many neurons we have in our hidden layers and output layers. So we are providing this information in our optimizer, and we are specifying that the value of our learning rate. After that, this line of code for I in range 0 to 50, it is simply means we have 450 epochs. 450 epochs. So now it is our prediction. We are providing our in our forward propagation our training data, and this forward propagation is same as we already written in our function of in our class of ANN. So after this we are getting our loss, and our loss is this is loss for our mean absolute error. And in my description I will give provide the link of all the loss functions and all the optimizers directly to the documentation. So, and this losses I am appending, I am saving into this empty list here. And after that I will print our epochs and with respect to our loss, like for one epoch how much loss we have. And this function I have used that it will try to say the optimizer that our initial derivative is 0. So we have to start from first derivative. After that, I will use loss dot backward. Backward is simply means do the first propagation in our back propagation. So optimizers of step, it is simply means it performs a single optimization per epoch. So after that, let me execute this code. So we can see it is working for each epoch. It is showing us the loss. We can see our loss is decreasing, and my number of epochs are 450. So let it execute is this, and I will talk about this. This is simply means I am showing my loss with respect to our number of epochs. So our execution is complete. Now let's plot the epochs versus loss. So it is simply means we are going to 0.02 450 epochs, and it is a list of our laws. So we can see our curve is going to down this, sorry, uh, our loss is decreasing, and after this value it is not decreasing so much. So we can say this is the number of epochs, this is the number of epochs, sorry, okay, so this is the number of epochs we need. After that it is not decreasing so much. Now our model is ready, our model is ready, so now we have to save this model. So for that we are using a torch.save function, and it is our model name and it is our file name. After that let me execute this. So now we can see in my directory our model is ready. So now we have to load this model and we will try to predict with some numbers. We can see while loading the same file, it will show us the number of hidden layers and our output layer. So after that, we already know that I have used standard scaling in above lines. So we have to perform our standard scaling first. So we have to convert after that into our tensors with a float, because PyTorch always PyTorch tensors should be always in our float values. So after that, this torch not do grad no underscore grad will tell us the our file that we did not need any differentiation, and it will not find any derivative. So after that, we have to write our name of our model. Then we have to pass, after converting into tensors, we have to pass this tensor in our neural network. So we can see it is giving us me 9.9, and our round is around 10. So we can see our number of rings is nothing but 10. So if I go in our data, so it is the same data I have take from our training data or test data. Let's show, let's see, is this value is correct or not. So we can see this is the same data I have written in my model to predict, and we can see our ring value is already 10. So can we say our model is predicting very well? So this is all about the PyTorch with ANN. In my next video, I will solve a CNN problem. If you are new to this channel, please subscribe the channel. This is all about today video. Bye.